Going to start chapter number 7, energy resources. So let's discuss about renewable and non-renewable resources of energy. Energy resources can be categorized based on their renewability. As you can see, we have energy resources, renewable and non-renewable. Renewable energy, you can see sun, hydro energy, bioenergy, wind energy, geothermal, whereas non renewable energy sources are fossil fuels, nuclear energy, natural gas, and coal. The definition of non renewable, these resources are finite and are depleted once used. Fossil fuels, coal, oil, and gas are non renewables. Oil and natural gas are projected to run out this century, while coal reserves may last for another 200 years. Nuclear fuel, like uranium, are also non renewable. Let's discuss about renewables now. These resources are naturally replenished over a relatively shorter period. Examples include wind, solar, and biofuel, where they used quickly and replaced. Example, wind blows again, sun shines again, new crops can grow again. An ideal energy supply would be based on renewables to ensure long term availability. Non renewable resources pose significant environmental challenges such as global warming from burning fossil fuels and radioactive waste from nuclear energy. Energy direct from the sun. Solar energy can be harnessed directly in several ways. Solar panels, these panels collect energy from sunlight to heat water for domestic use, washing machines, and central heating. Water inside the panel absorbs the sun rays and heats up. Solar cells, also known as photocells or photovoltaic cells, these convert sunlight directly into electricity. Large arrays of solar cells can generate significant amount of electricity. Some advantages of solar power. Number one, it's renewable. The sun is continuously uh, giving us energy. So it's a continuous energy source. Number two, environmentally friendly, does not contribute to global warming. Disadvantages of solar power are unreliable. The intensity of sunlight varies and is absent at night. Space intensive, requires a large area of solar panels to capture sufficient energy. Despite these disadvantages, solar energy is becoming cheaper and increasingly useful in remote locations. Example, powering refrigerators for medicines in Central Africa, emergency phones in deserts, or in spacecraft. For continuous power, solar cells are ideally connected to rechargeable battery to store energy for periods of darkness. Next is wind power. Wind originates from sun's uneven heating of the atmosphere, creating convection currents Warm air rises, cooler air moves in. Historically, windmills are used for grinding and pumping. Today, modern wind turbines generate electricity. Advantages of wind power: renewable wind is continuously providing us a natural environment, environmentally friendly, does not contribute to global warming. Some disadvantages of wind power: unreliable wind speed varies, no power is produced on calm days. Turbines require minimum wind speed of about 5 meters per second and are switched off if speed exceeds 25 meters per second to prevent damage. Dilute energy resource: a large wind farm, hundreds of turbines spread over several square kilometers, is needed to produce the same amount of energy as a typical fossil fuel power station. Environmental impact: wind turbines can be noisy and are often considered to spoil the landscape appearance. Next is wave power. Wave energy is derived from friction between wind and water, meaning its ultimate origin is also from sun. Advantages of wave power: renewable. Waves are continuous natural phenomena. Number two, environmentally friendly, does not contribute to global warming. Some disadvantages of wave power: number one, unreliable. Wave height varies and no power is produced when there are no waves. Number two, technical challenges: difficult to convert the up and down motion of waves into the spinning motion required for turbines in wave energy converters. Number three, high cost. Equipment corrodes in salt water and is susceptible to damage during storms. Next, we have hydroelectric power. Hydroelectric power has been used for centuries, initially with water wheels to drive machinery, example grinding corn, pumping water, weaving. Modern hydroelectric power station generate electricity by releasing water stored behind a dam to turn turbines when then spin generators. Advantages of hydroelectric power: number 1, it is safe, clean, reliable method of electricity production. Number 2, short startup time. Can quickly respond to sudden increases in electricity demand. This is particularly useful because demand for electricity fluctuates throughout the day, highest during the daytime and lowest at night. Unlike fossil fuels or nuclear power stations, which take a long time to start and stop, hydroelectric plants can be quickly activated or deactivated. Number 3, pumped storage system. Some hydroelectric stations can reverse their turbines to pump water back up to the reservoir during low demand. This stores energy as gravitational potential energy, which can then be released to generate electricity when demand rises. Some disadvantages of hydroelectric power: environmental impact, constructing new reservoirs floods land, potentially displacing communities and destroying wildlife habitat. Let's talk about biofuel now. Biomass fuels. Biomass fuels are organic materials derived from plants or animals. Number 1, wood. Wood is a primary biomass fuel, especially in many parts of the world, used for heating and cooking. It stores energy captured from sunlight through photosynthesis, often from recent past, decades to century ago. Number 2, other examples include animal dung and biogas generated from rotting vegetable matter. Global consumption and usage. Biomass fuels account for roughly 10% of global energy consumption. Through this is a rough estimate, as much wood consumption is not formally tracked. About two-thirds of biomass fuel is used in developing countries for cooking and heating. Developed nations, representing 25% of the global population, consume approximately six times more energy than 75% living in the developing world. Some advantages of biomass fuels. Number one, renewable. Plants and animals can be regrown or replenished. Number two, environmentally friendly, does not contribute to global warming. Carbon released during burning is reabsorbed by new plant growth, making it carbon neutral over its life cycle. Number three, can be burned on demand when needed, so it's reliable. Disadvantages of biomass fuel. Health problems. Burning biofuels, particularly indoors, can lead to respiratory and other health issues. Fossil fuels. Fossil fuels are non renewable energy sources formed from the remains of ancient organisms. The primary examples are oil, coal, and gas, which are typically hydrocarbons, compounds of hydrogen and carbon. Energy release called as combustion. This process releases the chemical energy stored within the fuel. Formation of fossil fuels. Fossil fuels are derived from organisms that lived millions of years ago. Coal formed from trees during the Carboniferous era. These trees captured solar energy via photosynthesis. After dying, their trunk fell into swampy ground and did not fully decompose due to insufficient oxygen. Over millions of years, accumulating material compressed these remains, transforming them into underground coal reserves. Thus, the light and warmth from burning coal today originate from solar energy trapped hundreds of millions of years ago. Oil and gas form similarly but from the remains of tiny marine organisms called microplankton. Major oil fields such as those in Arabian Gulf, North Africa, and Gulf of Mexico formed during the Cretaceous era. Environmental impact of burning fossil fuels. Global warming. Burning fossil fuels releases carbon dioxide into the atmosphere, which enhances the greenhouse effect and is primary cause of recent global warming. Coal produces more carbon dioxide than oil and natural gas. Number two, acid rain. Burning coal and oil often releases sulfur dioxide, which contributes to acid rain, damaging ecosystem and building. Now let's talk about nuclear fuels. Nuclear power, developed in later half of the 20th century, is a highly demanding technology requiring strict controls due to severe potential damage from accidents. Fuel, typically uranium, sometimes plutonium, both of which are radioactive materials. The process inside a nuclear reactor, the radioactive decay of these materials is accelerated through nuclear fission. The process rapidly releases the stored nuclear energy. Characteristics and comparison. Uranium is a very concentrated store of nuclear energy. A typical nuclear power station might receive one truckload of new fuel weekly. In contrast, a similar sized coal fired power station would require a trainload of coal every hour. A wind farm generating the same amount of electricity would need to cover a vast area, perhaps 20 square kilometers. Some countries, like France, rely heavily on nuclear power due to limited alternative resources. Excess power is often exported. Advantages of nuclear power: concentrated energy resource, high energy output from the small amount of fuel, relatively cheap fuel. Uranium itself is not expensive. Disadvantage of nuclear power: high initial cost. Building nuclear power station is very expensive. High decomposition cost, disposing of radioactive spent fuel and dismantling old tower stations are costly processes. Risk of accidents such as those as occurred before can release radioactive material over wide areas, causing long-term environmental and health damage. Let's talk about geothermal energy now. Geothermal energy harnesses the heat from the earth interior. Source: the earth interior is hot due to the presence of radioactive substances that have been releasing energy since the earth formed. Process: where hot rocks are found at shallow depths, water is pumped down, boils, and returns to the surface as high temperature steam. It generates electricity. Location: geothermal resources are typically found in areas with active volcanoes where hot rocks are accessible. Uses: besides electricity generation, it can also supply hot water for heating nearby homes and buildings. Advantages of geothermal energy: clean and reliable, no obvious disadvantage in terms of environmental impact. Disadvantages of geothermal energy: limited availability, only available in a few specific locations on Earth. Let's talk about tidal energy, incoming tides, estuary, turbine. Tidal energy is similar to hydroelectric power, that in that it generates electricity from moving water. Process: a barrage or dam is built across a river estuary. As the tide flows in and out, water passes through turbines within the dam, generating electricity. Advantages of tidal power: renewable, tides are continuous natural phenomena, reliable and predictable, tides are predictable, making tidal power a reliable energy source. Disadvantage of tidal power: environmental impact, flooding, estuaries can destroy wetlands, which are crucial habitat for wildlife, especially migrating birds. Shipping disruption, barrages can block shipping routes, using energy resources to generate electricity. Many energy resources are used to produce electricity for distribution. The general principle for thermal power stations using fossil fuels or nuclear fission involves several energy transformation. Number one, thermal energy production. Burning fossil fuels or nuclear fission produce thermal energy. Number two, steam generation. This thermal energy heats water in a boiler to produce high pressure steam. Number third, turbine rotation. The steam turns the blades of the turbine, converting thermal energy into kinetic energy. Number four, electricity generation. The turbine is connected by an axle to the generator. As the generator spins, a voltage is induced in conducting wires moving within a magnetic field, producing electricity. For energy resources that do not use fuel such as wind and hydroelectric wave tidal, a boiler is not needed. Instead, the moving air or water directly turns a turbine, which then drives the generator to produce electricity. Key comparison factors: number one, renewability, limited reserves, fossil fuels, and uranium nuclear fuel are non renewable. Plentiful reserve, alternative nuclear fuels like thorium are abundant. Renewable, all energy, other energy resources ultimately traceable to the sun, solar, wind, hydroelectric, biomass are renewable. A significant advantage of renewables in their minimal contribution to global warming once installed. Cost: distinguish between initial cost and running cost. Example: a solar cell has a high initial purchase cost, but the fuel sunlight is free. Nuclear fuel is cheap, but the cost associated with commissioning power plants are very high. Availability: the availability of resources varies geographically. For example, France relies on nuclear power, 75% of electricity due to few alternatives. Norway uses hydroelectric power 95% due to abundant rainfall and mountains. Iceland leverage geothermal energy where hot rocks are accessible. Reliability refers to the constant availability of the energy supply. Wind power, for instance, is unreliable due to variable wind speeds. Political factors like wars and trade disputes can also interrupt fuel supplies. Scale relates to the physical space required and the energy output. A compact fossil fuel power station can serve a large population, while a small household might need several square meters of solar cells. This is linked to whether a resource is concentrated or dilute. Next, we have environmental impact. All energy sources have some environmental impact. Fossil fuel cause climate change. Hydroelectric dams can flood farmland. Energy from sun, most of the energy we utilize ultimately originates from the sun radiation. Fossil fuels, these are stores of solar energy captured by ancient organisms millions of years ago. Solar panels and cell directly absorb the sunlight and heat to provide hot water to generate electricity. Wind caused by the sun heating different parts of the atmosphere unevenly, leading to air movement. Hydroelectric power, the sun's energy drives the water cycle, evaporating water from oceans and land, which then falls as rain on high grounds and is collected behind dams. However, some energy sources are not derived from the sun radiation. For example, we have tidal power, primarily depend on gravitational pull of the moon and to a lesser extent the sun, causing ocean tides. This makes it reliable even at night or on cloudy days as it is independent of solar heat and light. Nuclear power uses nuclear fuels like uranium, which were formed within the Earth 4.5 billion years ago when the solar system formed. Geothermal energy relies on the heat generated by radioactive substances within the Earth's interior, which have been continuously releasing energy since the planet formation. The source of sun's energy. The sun releases immense amount of energy not through chemical burning but through nuclear fusion. The processes in nuclear fusion, four energetic hydrogen atoms collide and fuse together to form a helium atom. Conditions this process require extremely high temperature around 15 million centigrade and pressure which are found in the sun's core. Plasma, at these temperature atoms are ionized, meaning their electrons are stripped away, creating a state of matter called plasma, positive nuclei and negative electron. Overcoming repulsion, atomic nuclei are positively charged and repel each other. A temperature of about 100 million centigrade and high pressure are necessary to overcome this electrostatic repulsion and force the nuclei close enough to fuse. Nuclear fusion reactors, artificial suns on Earth. Since 1950, scientists have been working to replicate nuclear fusion on Earth, aiming for a clean source of almost unlimited energy that would produce no greenhouse gases or radioactive waste. Challenges and solution: plasma confinement. The main challenge is containing the extremely hot plasma in the sun. Its enormous gravitational fields achieves it. Terrestrial fusion fuel, Earth based fusion reactor would typically fuse deuterium and tritium isotopes of hydrogen to produce helium and neutron. Energy extraction: since neutrons are neutral, they are not confined by the magnetic field and hit by the walls. These collisions generate thermal energy, which is then transferred via heat exchangers to heat water, produce steam, and drive a turbine to generate electricity. With this, we have finished our chapter. See you in our next chapter.